Let's learn probability tree diagrams. So before we start the tree diagram concept, let's see what is a probability. A probability of an event is number of successful outcomes over number of possible outcomes. So successful outcomes and possible outcomes, those are the keywords here. So which means that the probability of getting a heads when you toss a coin is successful outcome is how many times it can happen. It is 1. And how many number of possible outcomes are there? 2. So it is 1 over 2. And probability of getting a number 5 when you roll a dice is 1 over 6. Or probability of getting an even number when you roll a dice is 3 over 6, or which is equal to 1 over 2. So this is one basic concept of probability. And number of and there's one more thing, probability of not getting a 5 is equal to 1 minus 1 over 6. 1 minus probability of getting number 5. So that is equal to 6 minus 1 over 6, which is equal to 5 over 6. What it means is probability of getting a number 5 plus the probability of not getting a number 5 when you roll a dice should be equal to 1. So the total sum of all the probabilities, the total sum of all the outcomes of an event should always be equal to 1. Okay, so this is one concept which you have to learn. Now, to work with the tree diagram, what it means, what a tree diagram represents is, a tree diagram represents the pictorial representation of all the outcomes of events when multiple events are happening, or maybe one event happening multiple times. Okay, for example, I am tossing a coin twice. So what are the possibilities when I toss a coin twice? That is what I am going to represent using a tree diagram. So the first time when you toss, you will get a heads and you will get a tails. Okay. Again, when you toss it the second time, again you can get a heads or you can get a tails. Okay. You can get a head or you can get a tail. Okay, I'm sorry, let me just remove the S here, it's not required. Head or a tail. So this is the one, this is a tree diagram to represent. If I'm tossing it again I will have 2 branches here. Okay, and you can write the probability. A probability of getting a head is 1 over 2. Again the tail is 1 over 2. Again here the head is 1 over 2. Tail is 1 over 2. Head is 1 over 2. Tail is 1 over 2. Okay. Now similarly, if you have some other events, like for example, if you have 3 blue balls and 2 red balls in a bag, and you are picking a ball 2 random times, okay, or 2 times at random, and what you are doing is, after picking up for the first time, you are replacing the ball into the bag. Okay, so you need to draw the tree diagram for this. So the first time when you pick the ball, what will happen, like maybe I'll start with the tree diagram itself. So when I'm picking it for the first time, I might get a blue ball or I might get a red ball. So the probability of getting a blue ball out of this is 3 over 5, because there are 3 blue balls and the total is 5, and the probability of getting a red ball is 2 over 5. Okay, now we are replacing the ball into the bag, which means the number of balls in the bag is not changing. So when you do it the second time, the number of the probability of getting a blue ball is again 3 over 5. That's not change, and it's for the red, that is 2 over 5. So the same thing will continue here in this branch also. So the probability of getting a blue ball is 3 over 5, and the probability of getting a red ball is 2 over 5. Okay, so this scenario is where you are replacing the ball, which means that the situations of the event is not changing. Like always you have 5 balls in the bag whenever you are picking. In the first, this is the first one and this is the second draw of the event. So in both of the case, the situations are not changing. These events are called independent events. The events are independent of each other. So in the case of independent events, the probability of an event doesn't change. For example, in this case, the probability of picking a blue ball doesn't change from one turn to another. So here if it is 3 over 5, this is for the second time also it is 3 over 5. and for red it is 2 over 5. For the second row also it is 3 over 5. All over this experiment, the probability of picking the blue ball doesn't change. Okay, so let's take another case where you have the same thing. So 3 blue balls and 2 red balls, and you are picking it 2 times and not replacing. Okay, so in this case what you need to understand is, in the first case you have total 5 balls, and since you are not replacing, in the second case you have only 4 balls. Okay, so which means that these are not independent, or these are independent events, or sorry, dependent events. These are not independent, or these are dependent events. So now when you need to draw a tree diagram for not independent events, you have to be a bit more careful. So let's start by drawing the tree diagram. So I have a blue here, I have red here. So in the first case, the probability is simple. It is like 3 over 5, and this is 2 over 5. Okay, and for the second row, you have blue and red here. Again, you have blue and red here. So let us take this branch. Okay, now here already you have drawn a blue ball, but you haven't replaced it. So how many blue balls are remaining? You have only 2 blue balls. And what is the total number of balls? It is 4. So the probability is 2 over 4. Okay, now let's take the case of this branch. So the first row you draw a blue ball, and the second time you are trying to draw a red ball. So in this case, the red ball, there are 2 red balls, so it is 2 over 4. Total number is 4. So in all the cases, the total number will remain 4. Okay, so that is one thing. Now if you need to work on this case, in the first case you draw a red ball, so the number of balls, blue balls, remain the same, so it is 3 over 4. And for the second case, and for the last one, over this one, you already drew a red ball, so the number of red balls is 1, so it is 1 over 4. Okay, so this is how we work on the probability. And remember, when it is not independent events, what you have to do is, like, you have to work on the probability independently for each and every branch. Okay, you cannot just copy it, but in the case of a dependent event, the probability remains the same. But in the case of not dependent events, not independent events, you have to work on the probability for each branch separately. So let's do some problems and we'll try to understand this concept. So let's see some questions, and then we will be able to understand how to handle the tree diagram, how to draw a tree diagram. So let's quickly read the question. A bag contains 4 red balls and it's not 55, it is 5 blue balls. Rahim picks 2 balls at random. Calculate the probability that he selects the same colored ball each time, given that after each time the ball is selected, it is replaced. So the keyword here it is replaced, which means that it is an independent event. So that's one thing which you have to understand, because they will not specifically say that whether it is a dependent event or an independent event. We have to understand from the question whether the situation remains the same for each and every event. Okay, so here, since it is independent, the probability will remain the same always. So the probability of getting a red ball is what? 4 over 9, and the probability of getting a blue ball is 5 over 9. Now to draw the tree diagram, what you can do, you can draw the tree diagram with red and blue here, and the probability of red is 4 over 9, and the probability of blue is 5 over 9. Again, for the second time, you have red and blue here, so it is red and blue, so it is 4 over 9, 5 over 9, 4 over 9, 5 over 9. Okay, why? Because they are independent, the probability remains the same. Okay, now we are moving on to the second case. It's the same scenario. He has 4 red balls and 5 blue balls, but it is not replaced. So which means that these are not independent. They are dependent events. In this case, the probability differs. So we will start by drawing the tree diagram. So I have red and blue here, and I have red and blue in this case. So you have to work the probability of each branch separately. So for the red, it is 4 over 9, and blue, it is 5 over 9. And let us work on this branch now. So if there's red. Okay, in the second case, since it is not replaced, the total number will be 8. So for the second trial, the total number is 8 balls. So that you have to remember. So in the first case where I have highlighted, we have already picked the red ball. So the number of red balls in the bag is 3. So it is 3 over 8. And for the second branch here, sorry, let me just highlight. For the second branch here, you already picked a red ball. So the number of blue balls are not changed. So it is again 5 over 8. Okay. Now we are working on this branch here. So we picked up the blue ball. So the number of red balls doesn't change. So it is 4 over 8. And when you work on the last branch, it is, you already picked a blue ball. So the number of balls are changed. So it is 4 over 8. Okay. This is how we work on the probability. Now, what you have to do is like you have to find the probability that he selects the same colored ball each time. So to find the probability of that, what are the cases? Same colored ball each time means it is red and red and blue and blue. So these are the two things which you have to calculate. So if you need to calculate the probability of this, what you will do is like 4 over 9 times 3 over 8, and to calculate the probability of this, it is 5 over 9 times 4 over 8, and to find the combined probability, you just add both of these together. So it will be 12 over 72 plus 5 4s are 20 over 72. So you just add it together and you will get the total probability. Okay, let's work on another question. Natalie has 8 socks in a drawer. 5 of the socks are black and 3 of the socks are white. She takes out a sock at random, write down its colors and put it back to the drawer. This is the keyword here. Put it back into the drawer means the situations are not changed and these are independent. The events are independent. Then Natalie takes out a second socks at random and write down his color. So let me draw a tree diagram here. So 8 socks, total 8 socks, and I have black and white here. So the probability of black socks is 5 over 8 and the white socks is 3 over 8. Again, she is picking up, so it is black and white here. Black and white. Since they are independent even, the probability doesn't change. So it is 5 over 8 and 3 over 8. Also same thing, 5 over 8 and 3 over 8. Okay, so it's just to complete the tree diagram and we have completed that. Now let's look at this question. A football team has 2 matches to play. The probability that the team wins is 0.6. The probability that the team draws is 0.3. Draw a tree diagram with this probability. So here also you have to think whether it is an independent or a dependent event. Here since the win or the lose on the first event doesn't depend on the, on the first event doesn't depend on the second event. These are independent. Now one small thing which you have to think about here is they can win, they can draw, or they can lose. So which means that there are 3 combinations possible here. So one is win, one is draw, and the other one is lose. And for the win, again for the second time you can have win, draw, or lose. The same thing here. Okay, win, draw, and lose. Again same thing here. 3 options: win, draw, or lose. So the probability of the team wins is 0.6 and draws is 0.3. So the lose will be 0.1. How do we get it? 1 minus 0.6 plus 0.3, because the total probability should always be 1 and you get 0.1 here. And since they are independent events, always the probability of win will always be 0.6. So you can just copy it here. The same you can copy it to all the other branches. This happens only when the events are independent. When they are dependent, what you will do? You will have to calculate the probability differently. Okay. Now let's read this question. Kevin has a coin which is weighted so that the probability that it lands in head is 3 over 5 and the tail is 2 over 5. Copy and complete the tree diagram for 2 throws of the weighted coins. So there are 2 throws here. You have to find the probability. So let's start by drawing the tree diagram. So here you have head and you have tail. For the head it is 3 over 5 and the tail it is 2 over 5. If you see that for this event the total probability is 1. And for the second throw you have head and the tail. Here also you have the head and the tail. So is it independent event or not, or dependent event? It is an independent event because the consequences of the first throw doesn't have any impact on the second one. Since it is an independent event, again the probability is the same. So it is 3 over 5 and 2 over 5. Here also you have 3 over 5 and 2 over 5. Okay. Now, to work on the second question, what is the probability of two heads? So the probability of two heads is this one. So to work on the probability, what you do is like 3 by 5 over, 3 over 5 over 3 over 5. That's equal to 9 over 25. Okay, this is the answer for the first question. To work on the second question. To work on the third question, find the probability of getting one head and one tail. So those combination will work one head and one tail in either orders, or you can have tail and the head. So you work on the probability of this one first, which is 3 over 5 times 2 over 5, plus work on the probability of this one, that is 2 over 5 times 3 over 5. So you add these two together and you will get the probability of this one. Now let's do this question. A bag contains 3 red cubes and 2 blue cubes. A cube is taken at random from the bag and it is not replaced. So which means they are dependent events. So which means you have to work on the probability separately. And the second cube is taken at random. Draw a tree diagram. So I'll start with the first tree diagram. So which is red and blue. And the probability of getting a red cube is 3 over 5 and getting a blue cube is 2 over 5. And since it is dependent events, you have to work on the probability differently. So let's see how the probability will turn up for the other instances. So let's work on this one first. So you already have taken a red ball. So the number of red balls is red cube is 2 now, and the total number of cubes will be also be 4. So it is like 2 over 4. And for the next branch, what will happen? The first time you have taken red, so the number of blue cubes haven't changed, so it is 2 over, and the total number of cubes is 4. So again that is 2 over 4. And for the third one here, for this one, first we took a blue one, so the number of red ones haven't changed, so it is like 3. Okay, 3 over 4. And for this one, the blue balls, it is 1 over 4. Okay, so this is how we build up the probability. Now for the second question, find the probability that both of the cubes taken out are of the same color. So which means that this one and this one. So what you do is you find the probability of these two and add it together. So the probability of this one is 3 over 5 times 2 over 4, and the probability of this one is 2 over 5 times 1 over 4, and then you add both of these together. So which you will get 3 over 5 times 2 over 4 plus 2 over 5 times 1 over 4. You can just simplify this 1 over 2, and this one will also be simplified. So it is 3 over 10 plus 1 over 10, which is equal to 4 over 10. Okay, now let's work on the probability that the two cubes are of different colors. So to find the probability of that, which are the branches, you have to calculate this branch and this branch and add it together. It's the same like before. So it is like 3 over 5 times 2 over 4 plus 2 over 5 times 3 over 4. Just simplify it and put it into the calculator and you will get the value of this. I hope you are able to understand this concept of drawing a tree diagram and finding the probability of multiple events. So please try out some exercises from your textbook, and then if you have any doubts, please come back to me. Thank you.